Hello everybody, Chaz Large here with another Fix It video for you, and on the bench today we have a bit of a beastie. This is a Tascam DA-30 DAT, that's DA digital audio tape deck, which I'm told basically the deck doesn't work, the rest of it does. So the lid is loose, the screws are missing, not quite sure where they've gone, but I've got other bits of packaging that it came in. Anyway, let's plug it in and see what happens. We've got a knob missing here for a start off. Power on. Okay, so power's on, and we've got a display that says close and then says open. Oh, so obviously part of the mechanism is working. So let's just press close, see what happens without a tape in. And it says open again. That says to me something's wrong with the mechanism or the electronics controlling, or the electronics of the mechanism telling the processor that controls it whether it's open or closed or not. And usually if it comes straight back out, there's usually some sort of slide switch or some sort of end stop switch that when the deck goes in hits that switch, and that tells the processor that the drawer has gone all the way in. As it's come back out again, I suspect that that's possibly not getting in there. So let's just try that one more time. It's same as saying close and saying open again. So I'm not going to risk putting a tape in it until such time as I can get that drawer to close and stay closed electronically. As for the rest of it, well, we won't know much about that until we can get the rest of the deck checked out. So let's power it off, take the lid off and see what's going on inside, see if there's anything obvious. Right, God, it is a big heavy beastie. As I said, the screws are missing. Luckily the lid comes off fairly easily, and boy oh boy, we have got a bit of a circuitry which is actually quite good. Where's my camera? My camera's totally in the wrong place, pushed out of the way by a previous job I was doing, but there we are. Right, so here we are inside the deck and looking down at it, and we can see that we've got a main PCB here with processor, and these look like driver ICs to drive motors, and I dare say that's the motor connection. Yeah, somebody's been in here before because the connectors have actually got handwritten numbers on them, so somebody's probably had the deck out and checked for various stuff. I'm not the first obviously into this for obvious reasons. So again, from previous experience, drive controls to the driver type chips are usually the area to start looking for stuff like that, but it's determining whether the deck is actually going in and out correctly. Now I can already see on here on the deck itself, if we have a little look at the deck in close up. Right, on the deck here we've got a little circuit board with what looks like some switches possibly. We've got a motor, that's obviously the motor that drives the tray in and out. There's another motor which you can see over here, which is presumably doing the loading of the mechanism. And there's the actual DAT mechanism. It looks very much like a miniature videotape. So they basically load the tape around the head drum, and there's the head drum there, and that's spinning freely. So is it the fact that it's not closing switches and so on? So yeah, so there, that tray goes in and comes back out again. Now there's a switch just under here, which I can see, and I might be able to get this in a position so that you can see it here as well. So under here is a little switch there. So as the tray goes in, there's a bar, and that should be pressing that switch. You can't see it any more than that, but it's going in there. So that should be pressing that switch there to tell that that's open and closed. So let's see if that changes anything on the display if I manually close it. Find something more angular to press that up with. Right, there's no change in the display. But having pressed it slightly, as the tray starts to go in, if I press that, the tray actually stops moving. So it seems that this switch is actually functional. So you can see I'll press the button and it closes. I'll press it again and open it. But if I press the close and then press this switch immediately, see it stops part way as though it's operational. So I would guess that that switch is actually functioning. It's telling the processor that it has actually gone all the way in. Now obviously that's not the be all and end all. That's telling it that the tray has closed. Is there another part of the mechanism that should then come into operation to say that there's something else in? Do we have to have, we shouldn't have to have a tape in the tray for the tray to close. You wouldn't be able to just close the tray and expect it to keep popping back out again, you know, if you don't put a tape in it. So it shouldn't be reliant on there being a tape in. Is it that this switch here that tells it that it's left the end, the out, although I suspect that that's probably working as well. So let's just try this same sort of trick, so that when we I've got to be quick here, so when we press eject on the button, because the button's obviously working, see, and I think that yeah, the light, the open and close LED on the front is actually going out as soon as this drawer closes. So I'm going to guess that this switch is also working okay. So I'm going to just try it quickly. Yeah, see, it stops. So that switch is also working. So that's a little bit of diagnostics out of the way for that respect. So is it possible that the mechanism has to then go further once this drawer is closed? Is it possible that the mechanism has to go further, or something else has to happen to say to the processor, okay, the drawer's closed, let's try loading a tape down? So perhaps the mechanism that drops the tape from the drawer into the mechanism here, because obviously what's got to happen is the tape's got to go in and then drop down. So perhaps this part of it, ooh. Okay, let's risk putting a tape in and seeing what happens with the tape in, see if that makes any difference at all. No, it doesn't make any difference at all. So the tape physically being in there is not making any difference. But I would suspect that there is part of the mechanism that has to do something else to say, right, the drawer's in, the tape's going to be dropped down. It probably goes in, down, and then just sort of sits there. So the tape in recognition is not just the drawer closing, it's actually in and then drop down. So it's the drop down bit that's not working. Right, where do we go from there? So we could take the deck out and just physically move it, make sure it's actually doing what the deck should be doing. So what I'm going to do is I'm going to take the deck out, disconnect these connectors, take the screws out, etc. But I'll put that through at high speed. I won't rub it on while I'm doing that. Right, having got the deck out, as I was taking the deck out, I realised that there was two other connectors that had already been unplugged from this bottom board here, and they've been marked up by whoever's been into this before, 6 and 5. So they go into those two. Probably there's no real reason to mark them anyway, because they're all different plug sizes, so they'll only go in one way. This one here, this is the head amplifier. This is the head amplifier for the rotary or helical head. So this is the motor drive assembly. So let's reconnect these three main ones from the top. We'll leave that head amplifier off. We don't need to worry about that one. Let's pop these back in and see if we got any different results now. So that one will only go in there. It will go in there, but there's one pin too short and it won't go in that one. So these can only go in one way around anyway. But always a wise precaution if you're unsure when you're taking plugs out is to label them in some way, mark them, whatever. Okay, so we've got all the connections apart from the head amplifier back in. The spring here was the spring to pull that, make sure that tray was closed properly. I don't think we need to worry about that for the time being. So, power it back on. Alright, still says close. And it's opening the drawer. Right, so let's close the drawer. And still nothing. So it's still no better off. Okay, it's not doing anything more. So I suspect whoever was working on this had probably got to the stage where they'd identified that the problem is to do with the drive to the loading motors here, which is coming off of this connector. So this is the tray motor. This is the head motor. Is that the head motor or is that the... Oh, sorry, that's the capstan. Beg your pardon. That's the capstan motor that pulls the turns the capstan around. That drive belt there looks like a elastic band, to be honest. So I guess that's driving the take-up spools. So we've got another motor here which drives the deck loading, I would suspect. So let's take the plugs back out again and look at this manually on the bench. So we've got a little bit more space to work on. Right, well, I've got the mechanism, the whole mechanism out. We know that the top tray works, but we suspect, or I suspect, that it might either be a mechanism failure, that the mechanism is not dropping the tape from the tray down into the deck, or it could be a control circuit not giving the right voltage. So I need to just double check, isolate one part of the system from the other. So I want to go through and check the whole deck operation physically without the control circuits, otherwise you can get yourself really confused. So what I've got, my little bench, my smaller bench power supply, which I've got set up, and the beauty of this little power supply that I made many years ago and I've recently rebuilt is that I've got an on-off switch which I can go forwards and backwards, so it quickly reverses the connection positive and negative on there. So these motors on these types of deck tend to be somewhere around 3 to 5 volts. So I'm starting off with a 3 volt supply out of here. There's no supply at present, so I'm just going to pop the connection on this tape on the loading tray, which we know works, just to prove the sort of process. Right, so what I'm going to do is I'm going to put the power supply across this motor. Just holding it on. I could solder wires on and all that, but it's a bit pointless when I can actually just hold it there. Just temporarily hold it across the motor connections. Hang on to the deck as well. Now when I turn it on, hopefully the motor should go one way. Yes, it's going out, and that's going backwards. So we know for a fact that that motor works anyway. So let's push the drawer all the way in. Now the loading mechanism motor which drives the deck up and down is this mechanism here by the look of it. So I'm just going to see if I can manually wind it, because the gears are easily accessible. So if I wind that, does the whole deck go up and down? There it is. So yeah, so the deck goes down. Sorry, the tray goes up and down. So let's just make sure that that motor is actually doing what it's supposed to do. In fact, we don't need to see that side, so long as we can see those gears turning when we put bolts across the motor. Right, there's one way, and there's the other way. So we can pretty much rule out the motor drive as being the problem with the tray loading. What we now need to determine is how does the system processor know that this tray is up or down. So there must be some kind of switch, what I would call a mode switch, that determines how that the processor knows whether it's up or down. Could it be? Yes, in fact, actually, if I'd have looked a little bit more carefully, we've got a switch here, look, just on this mechanism, and that switch there, and there's probably another one. Oh yeah, there it is, just there. So these are the switches here which determine whether the deck, the lifter mechanism is up or down. So let's just run that again and make sure that the switches are being activated when at each end of the travel. I guess there's a lever here that presses that one, so let's run it one way. Right, yeah, there it goes. Yeah, so these two switches here and here determine deck up, deck down, or tray lifter up or down. Now what we need to do is to trace the wiring of those, which are these three wires here. So that's an orange, a red and a black. Orange, red and black. They come around here. Orange, red and black, and there's the grey and the another orange, grey, two oranges, wonderful. So we've got the wires, two motor wires, orange and grey, and we've got the orange, red and black, which come round to this connector here, CN12, on this part of the circuit board. So we should be able to go orange to, say, that one, yeah, and grey is that one. Is that grey, second one? Yeah, first one, okay. So that's going to be the motor. Now let's just manually crank that. So we've got the three connections there, orange, red and black on these three connectors, and hopefully none of these should be connecting. Now if we close that mechanism up, two of these should connect. Yep. So I'm guessing the common one is probably going to be that one there. So we crank it round to there. There we go. Yeah. Okay, so that's getting back to there. The motor's being driven by those two on there. So it would appear that the mechanism itself is working as it should do, but what we're not getting is drive to this motor here to drop the deck down. And it could be that either this connection through from here through these other wires up to the processor is not getting there correctly, or it could be that the drive power to that tray is not getting from power driver on the circuit board to drive the motor. So we don't know quite where the problem is yet, other than it doesn't appear to be on the mechanism. So I think the next thing we need to do is to get the circuit diagram for this, see where CN12 connects to on these three, because one of those three should be connecting up to the main circuit board to tell us, feed that supply voltage for the motor and also the feedback from those switches to the processor to see what's happening. It could just be simply that the processor, part of the processor, is working and the drive it's not telling that motor to drive, or it could be that that feedback from those switches is not getting to the processor to tell the processor that the deck is up or down in the lift position. So let's get the manual out and have a look at that. Right, I've got the deck back into the main chassis and reconnected the connectors. So what we're looking at is the CN1, which is the connection that we said was necessary for the switch here, Tascam switch. If we follow that up, there we go to CN1 here, and that's on pins 9, 10, and the common for the switch is pin 11. So that's the common, the center of the switch there. So the two switches that are underneath the deck. Now if we look at the actual main circuit diagram for where that connects to, we can see there's J401 is where it connects to. So actually on the overhead you can see CM1 there is this one here, and that connects to J401 over there. So if we look on that J401, we've got the pins 9, 10 and 11, the two switches and the COM, and if we trace that common back across here, it goes all the way across here, down here on the circuit, and eventually ends up here as a common ground point. So we know that's a 0, a low level. So what we should be looking for on these switches here, pins 9 and 10, this is the switches for the they call it the Tascam, not to cassette control. I'm not sure why they use that acronym, or whatever, but anyway, that's what it is. So what we should be looking at here is highs or lows getting into this integrated circuit there, U462, which we'll have a look in a minute. But let's first off identify pins 9, 10, 11, make sure pin 11 is common or ground, and then check switch 4 and 3 or 9 and 10 there to see what kind of voltage levels we've got. We'll put the meter onto continuity. I've not got it plugged in. 13, 12, 11, that's ground, 10. Right, so I've moved the deck. Let's move the deck back. So that's closed. That's now open. I'm moving the deck so the deck drops down. So 10. Right, so that's the other one. Yeah. So it was 9 I was on before. So 9 shows it's down. Move the deck manually, and there it is. Right. So we know that the switch is getting all the way up to this point here. So now so we know that the switch conductivity is getting all the way to here. So let's just now see on one or either of those pins there voltage occurring. Okay, so we've got 5 volts on that pin there. So we know we've got 5 volts getting to there, and we should have 0 volts on the next one, which we have, so that's okay. So that means that this feedback into this chip is working. Is this chip telling the processor here that the deck is not in that loaded position? That's what we've got to work out next. So let's see if we can identify what this chip is. U462, it's an LC7800, and let's see if that's what that chip is. And here is the circuit diagram, and an input expander is what it's called in the manual here. And it's quite a complex chip, but it's basically a logic array, and we're looking at the various pins that we want to see input, which are pins 10 and 9, and they come into pins 3 and 4 of the IC. So pins 3 and 4 are what we're looking at. So there's pin 4 there, which is marked as _A1, and pin 3 is up here, underscore, I want to say underscore, not A1 and not A2 is what they should be called. So they go into these logic gates and control the outputs to pins 25 and 26. So obviously different combination of inputs and outputs across these output pins 23, 24, 25 and 26 is what determines the processor from being able to identify what inputs are happening. So really what we need to look at, we can't see obviously what's going on inside the chip, but we can see what's coming out or changes in state when we move these switches. So we're looking at pins 25 and 26. So let's see what we've got coming out of pins 25 and 26 in terms of logic levels. So what we should be able to do is see what kind of output we've got from pins 25 and 26 on the scope, which we've got connected. So we are 28, 27, 26. I've done a little marking pen there, and we can see that we've immediately got a high level. Okay, as you can see there, a logic high level. So if we were at the moment with the drawer out, let's close the drawer and see if we get any change in that level, because those pins are also used for the other switches. So nothing there. In fact, actually, if we look carefully, we can see that it's actually strobing. I'll just turn the brightness up. There we are. We've actually got processor pulses sitting there all the time. So with that going in and out, let's go to pin 25 and see if we get any change. Nothing specifically there. So what I'd like to try and do is to manually crank the mechanism through for the carriage up and down, which I should be able to do by manually cranking the gear underneath. And there we can see that those switches are changing, or that switch is changing. So obviously the processor is receiving a signal. If I crank it the other way. Now another little test that we can try is to see what happens, because at the moment we've got the deck sitting with the loading position. The tray is out. If I close the button, the tray goes in. Okay. Now what should happen is when that tray goes in, that tells the processor that the tray's gone in, and then the drive should then drive the deck, the carriage down with the cassette in it. So what I'm going to try, I'm going to power it off. I'm going to power it off once I've closed the drawer, like that. I'm now going to manually crank the gear mechanism to actually drop the carriage down. So now if the processor is accepting those controls properly, we'll see if something changes in the operation of it. We'll know that the processor still thinks that that carriage has dropped. So let's power it on. And now the cassette lifter should actually lift up of its own accord, because the deck knows that the cassette is down. So the fact that it's not lifting up would tend to indicate that the processor isn't telling the drive motor to activate. So therefore we need to look there. Okay, so having confirmed that the mechanism all seems to be physically working, it seems to be that the problem is down to the actual drive of the motors, whether the drive is actually being driven correctly or not. We can see from the circuit that the cassette up and down, the lift motor, if you like, it's called Tascam here, that's driven by IC464. So if we look at the chip itself, we can see that we've got a chart here at the bottom which shows the input controls for the two different sets of drives on this IC, in 1 and in 2, and in 3 and in 4. And the ones we're interested in, the actual IC itself, the outputs we're looking at are from pins 3 and 10. So that is 3 and 10 is there and there. So the inputs we're looking at are 1 and 2. So if we actually have a look, just for simplicity's sake, I'm using the scope as just as a logic level. If we look at the input to pins 2 and 11, so there's pin 2 there, which is currently high. And pin 11, that's also high. So we're at the point down here in the chart where we've got two inputs, pin 1 and high there. So what we should see is a change in one or either of those when we want to drive the motor, and that will tell us that the processor is doing it. So if we put this on pin 2 to start with, and we now close the drawer, and we can see that goes low immediately. So that should be driving pin 2 going low, which is there. So that's IN2 going low from with 1 being a high, because that's there all the time. That means the output should be going high. So that's out 1. So we should be seeing a positive voltage coming out of pin 10. Okay. So there's pin 10 there. So when we do that again, so if we close the drawer, and no, we don't get a high out from there. Okay, so actually preempted this little bit by disconnecting the motor. So there is no output physically. If we go back to the circuit, what I've done is I've physically disconnected these two pins here to see if this output will go high from pins 3 and 10, and they don't. So what we can now try, if we what I've done is I've actually reconnected. Let's get rid of the window there with the circuit for a minute. What I've done here, let's get rid of the scope as well, is where I've disconnected those two pins from that connector, I've connected my power supply, my little reversible power supply to this. So what I'm going to do is when the drawer closes, I'm then going to turn the power supply to drop the deck down on here, and let's see what happens at the on the display. So drawer close, deck down. Okay. And with that, what we've now got is a display of 000, and the open close LED is out. So as far as the processor is concerned, that's now actually got a cassette down and in place. Okay, so if I now reverse that process, so I would raise the mechanism back up with the motor and open the drawer. Okay, what I can now try is at my dummy cassette, pop this in. Now because it's not got any tape in it, okay, so I'm going to press close, drop that down. Now with the cassette down, the light it's still saying close. So for some reason it's still not determining that there is a cassette in place, although the actual mechanism looks like it's detected it because the head has started spinning. So let's raise that up and take it out. Just try that again. Right, that's the deck all the way down, but it still hasn't recognised it. But with the carriage going down without the cassette in, it does recognise it, which is really odd. So I'm just going to take this back out and try a proper full cassette. See if that makes any difference. So let's try this one with actual cassette in. And it's still saying close. So it's not fully registering that a cassette is dropping in. And I'm not sure why that is. So the thing is, what I've made the decision prior to doing this little bit of the video is that IC, that drive IC, is at fault. So I'm going to order up some ICs. When I get those in, replace both of those drive ICs and try it again, see how we get on. So at the moment, that's as far as we've got.